Alrighty, so we are on 3.2 now, which is about projectile motion. We will be going over 3.2a and 3.2b today. They're pretty short. This is not a super long lesson. I lumped them together, and they're pretty much the same thing in both lessons. Well, not exactly, but anyway, so we're going to look at 3.2a first. What exactly is a projectile? So before I get into what a projectile is, we're going to look at all the things we've covered so far. So far we've covered Unit 1, and in Unit 1 we described one-dimensional motion of an object, and then we called these the kinematic principles. And this was basically, we talked about all of the different ways we can describe the motion of object: acceleration, velocity, speed, displacement, distance, all of those things. So momentum we even talked about. So that's what we talked about in number 1. We talked about kinematic principles. We described one-dimensional motion. In Unit 2, remember, that was all about Newton's laws. And remember, we used Newton's laws to help explain motion and changes in motion of objects that were moving or at rest in one dimension. So now what we're going to do is we're in this part of the course, we're going to take the kinematic principles and Newton's laws, and we're going to use them to explain motion in 2 dimensions. All right, so remember, 2-dimensional motion just means not just left, right, up, down, right? We have 2 dimensions now of motion, like we've been doing in 3.1. Okay, so I just want you to understand where we've been and where we're going with this. So this is what we're going to be doing now. We're going to be using these kinematic principles mixed with Newton's laws in describing or explaining motion in 2 dimensions. Okay, so now let's look at projectiles. What is a projectile? A projectile is a moving object upon which the only force acting on the object is gravity. All right, pretty straightforward. So if there is an object and there is no force acting on it, then it's not a projectile. If there is an object and there are 2 forces acting on it, it is not a projectile. A projectile is an object with only one force acting on it, and that force that's acting on it is not just any force, it has to be gravity. So if we were to draw the free body diagram of a projectile, the only force acting on the projectile, the only single force acting on the projectile is the force of gravity. So that means if we draw the free body diagram, this is how the free body diagram of every single projectile looks, because that is the definition of a projectile. So this is the free body diagram. This is an important little bit of every projectile. So my question for you is, what about objects that experience air resistance when they're falling? Because obviously you know that a projectile is something that's falling, right? Something, if only force of gravity is acting on it, it's something that's falling, okay? So what about an object that is falling and experiencing air resistance? Well, then that's not a projectile, because air resistance, remember, is a type of force, and it's pushing back up on the object in the opposing direction of gravity. So by definition, an object that has air resistance cannot be a projectile, all right? So we have some different types of projectiles, 3 different types. And the first one that we have are dropped projectiles. And we'll say dropped projectiles. And this is only considered a projectile if air resistance is negligible. Meaning it's so tiny we don't count it, or it doesn't exist. I mean, it's always going to exist. But anyway, only if air resistance is negligible. Okay. All right. So anything that's dropped, someone dropping a rock, someone from a cliff, someone dropping a ball from their hand onto the ground, dropping a crumpled up piece of paper, anything that has negligible air resistance is considered a projectile. If a dropped object is considered a projectile. We also have thrown upward. We have two types of thrown upward. So the first type is a thrown upward vertically projectile. And what this means is I am standing here and I'm going to throw a ball directly above me, and it's going to come down back on top of me if I don't move. So vertically means it's thrown straight up into the air. All right? As opposed to our third type of projectile, which is thrown upward, but not vertically. It's thrown upward at an angle. Projectile. And this would be if I'm standing here, and rather than throwing it directly up on top of my head, I throw it out this way. That's a thrown upward at an angle projectile. Okay, so again, going back to our free body diagram over here, no matter what type of projectile we have, whether the projectile is moving down, or it's moving up, or it's moving to the right, or it's moving up and right, or down and right, or up and left, or up and left, or down and left, whatever it is, this is the free body diagram. This is the free body diagram of every single projectile. Pencil. This is the free body diagram. Applies to all projectiles, regardless of how they're thrown or dropped. We'll say regardless of type. All right, so whether like I said, whether I drop something, let's get that picture up here actually. Okay, so here I have a dropped projectile. Here I have a thrown vertically projectile. Thrown upward vertically. And here I have a thrown at an angle. Okay, so if we were to draw the free, first of all, okay, the only force acting on this ball from the time it leaves his hand until it hits the ground is the force of gravity. Same thing with this. As soon as it leaves his hand, there's a force of gravity pulling it down. Even though it's going up, there's a force of gravity pulling it down. Same with this one. So if I wanted to draw the free body diagram of the ball in this dropped situation, it's going to look like this. If I wanted to draw the free body diagram of the ball in this situation, same thing. If I wanted to draw the ball in this situation, same thing. And remember, if I wanted to actually figure out the value for the force of gravity, I would need to know the mass, mg, right? Force of gravity was the same as, there we go, mg. So I'd have to know the mass of the ball, because I already know that the force of gravity is 9.8 meters per second squared. So I would need to know the mass of the ball. But it doesn't matter. In this situation, the force of gravity is the same in all three situations. And that's the only force that's acting on the ball in all three of these scenarios here. Okay. All right, so we need to talk about some misconceptions and do some brain retraining in order to really understand and proceed with this idea of projectiles. So the first misconception is that objects that are projectiles that are moving upwards, so if they're thrown vertically or thrown at an angle, whatever it is, these objects the only force acting on them, because they're a projectile, the only force acting on them is the force of gravity. So don't get confused, because I'm going to try to trick you, so don't get confused by that. The only force acting on any projectile ever is gravity, okay? So the belief that force causes motion, and if there's upward motion, then there must be upward force, that's wrong. It's completely wrong. Don't get stuck in that. So be careful of that on the homework. And let's talk a little bit about why that's wrong. So remember Newton's laws. Stated, all of them together, that force is only required to cause an acceleration, not motion. Force is only required to cause acceleration, which means speeding up or slowing down. We do not need a force to cause motion, okay? So that's very, very, very important. Force is only required to cause an acceleration or to maintain an acceleration, okay? Forces aren't required to keep an object in motion. So in the case of our projectile that's moving up, there's a downward force and there's a downward acceleration because of that. So the object is moving upward and slowing down. So the reason I'm beating the dead horse on this is because we're going to look at this picture here of a cannon shooting a cannonball. Okay, so